Hi everyone. Today we're going to be preparing a sample of highly oriented pyrolytic graphite, often abbreviated as HOPG, for use in a scanning tunneling microscope. The end goal is to see those iconic graphite layers and hopefully achieve atomic resolution. So let's dive in. So what is HOPG? HOPG is a form of graphite with extremely well-oriented layers. Because of its uniform crystalline structure, it's commonly used as a calibration standard in STM experiments. Here is everything we'll need for this demonstration. First is that HOPG chunk. It looks like a simple piece of graphite, but its crystal structure is actually extremely ordered. We'll also need specimen discs. I know it says these are AFM specimen discs, but I measured the resistivity and it will work great for STM too. This is important since STM requires conductive substrates and samples in order to even work in the first place. This metal piece will act as our substrate. It's compatible with our Nanosurf EasyScan 2 STM sample holder, but substrates can also vary. We'll also be using silver paint. This paint provides a conductive path between the HOPG and the metal substrate, and we'll permanently attach it. We'll also be using some tweezers to handle the HOPG, as well as gloves, which I'll put on now. It's worth noting that a lot of times skin oil can contaminate these samples. You wouldn't want skin oil to get onto the HOPG sample. And then also, if you're going to be cleaving this, we won't do that in today's demonstration, but if you're going to be cleaving layers from the HOPG, you're going to want a razor blade or adhesive tape, depending on the way that you're going to be doing the cleaving. Also optional, some Kim wipes and ethanol or whatever you want to clean your sample disc ahead of time. So I ordered these directly. They're probably clean, but we're going to make sure by cleaning the substrate before we even do anything. So first I'm going to clean the sample disc. Always remember to work in a well-ventilated area when handling solvents or silver paint. Wear gloves and avoid inhaling any fumes. Safety first. I recommend using these Kim wipes since they won't leave behind any fibers on the sample. So now that we've ensured our steel substrate is clean and we've wiped it down with some isopropyl alcohol, we're going to let it dry thoroughly, as any dirt or residue can interfere with the conductivity or adhesion of the sample. So first step of this, shake or stir the silver paint as necessary. We will use a small brush to apply a tiny drop of silver paint on the center of the steel substrate. We don't need much, just enough to create a thin layer that will secure the HOPG in place. So we want to carefully position the HOPG chunk on top of the silver paint using tweezers, and we're going to press lightly to ensure a good contact. So we're going to make sure the HOPG sits firmly. We don't want it wobbling when we put it into the STM system. And then next, we're going to allow the silver paint to dry according to the manufacturer's instructions. This can take from a few minutes to an hour, depending on the formula. And then after that, we would cleave the HOPG, the top layer. We're not going to do that right now since the paint is still wet, and you want to do that right before taking an STM measurement for the best results. But there's two ways to cleave a layer of HOPG off the top. One is to use a piece of adhesive tape and simply peel it off. Another is to use a sharp blade and scrape it off. And cleaving is a very important part. Getting a fresh layer of graphite exposed is very important, since that's how you get a smooth, atomically flat surface for STM imaging. I'll be releasing another video showing hopefully the cleaving process and STM imaging in that video. And if all goes well, under an STM like the Nanosurf EasyScan 2, you'll be able to observe the steps between graphite layers and potentially resolve individual carbon atoms if the conditions are optimal. So a couple of tips. 1, keep the workspace clean to minimize contamination. 2, and again, this will be coming in a future video, but if we don't see atomic resolution at first, we'll try to re-cleave or adjust the STM's parameters, like the bias voltage, tunneling current, and tip approach. And then 3, the temperature and vibration control are crucial for ultra-high resolution. So any way that you can dampen vibrations is going to help. So that's it for preparing an HOPG sample for STM. It's really all about keeping things clean, using a good conductive connection, and getting that nice fresh graphite surface. If you found this video helpful, please give it a thumbs up. Don't forget to subscribe for more science and tech content. And if you have any questions, please leave them in the comments. That's all for now. Bye.